Morning students, continuation of physical chemistry. We have 5 chapters in physical chemistry. One is solid state, chemical kinetics, electrochemistry, surface chemistry and solutions. Solutions and surface chemistry both are potential. And already I started electrochemistry last videos. I did only 3 or 4 videos. Okay, in continuation, we'll see electrochemistry. After this, we'll see chemical kinetics and solid state. Okay, continuation of electrochemistry. We'll see electrochemical cell. Electrochemical cell. Okay, the cell which convert chemical energy into electrical energy. Chemical energy into electrical energy we call as electrochemical cell. What is the electrochemical cell? The cell which converts chemical energy into electrical energy we call as electrochemical cell. Okay, while chemical energy converting into electrical energy, the free energy decreases. Here, free energy of that particular molecule decreases. Free energy of that particular molecule decreases. Okay, free energy is nothing but delta G. Delta G decreases means it should be negative. Okay, here delta G means it keeps free energy, it is negative. Change it from, okay, decrease means, okay, negative value here. Next, this electrochemical cell also called as galvanic cell. It is also called as galvanic cell or Daniel cell, voltaic cell. Voltaic cell. And the best example for this galvanic cell, voltaic cell, Daniel cell. Daniel cell. Okay, Daniel cell is also nothing but galvanic cell. All are same. When we use the zinc as one of the electrode, when we use the zinc as one of the electrode, we call as galvanic cell. Galvanic means zinc. Galvanic means zinc. Okay, in continuation, we'll see the Daniel cell. Daniel cell. Okay, it is also called as galvanic cell. Okay, it is also called as galvanic cell. First, we'll see the construction of Daniel cell, reactions at Daniel cell, calculation at Daniel cell. We'll see. Okay, first, what are the steps involved in Daniel cell? One first step, construction of Daniel cell. Construction of cell. Second one, reactions at cell. Okay, third one, calculation of EMF. We'll see what is the meaning of EMF, electromotive force. And fourth one, representation of Daniel cell. Representation of Daniel cell. These are the steps involved in when we explain the Daniel cell. First, we will see the construction of cell. First step is construction of cell. Construction of Daniel cell. Okay, when we construct the Daniel cell, okay, always according to the IUPAC, every Okay, cell contains two electrodes, one is anode and cathode. Anode always present at left side, cathode always present at right side. This is the one principle according to the, okay, here, according to the IUPAC. Or anode means, okay, by the alphabetical also we mention like anode is present for anode start with A, cathode start with C. First you write A, then you write the C. Okay, here first positive, first negative, then okay, first positive and then write the negative like that. We mentioned like that. Okay, here when you are constructing the, okay, this Daniel cell, we will take here two chambers. Here we will take two chambers. This is the one chamber. Okay. Here I am taking one more chamber. This is the one more chamber. Okay, this side this acts as a cathode, that side acts as a, which is left side acts as a, which is left side, that is acts as a anode, which is present at right side, that acts as a cathode. See here. Okay, here keep one electrode or dip one electrode and arrange one electrode which acts as a anode, which acts as a anode, and here also keep one electrode or dip one electrode, dip one electrode, okay, one electrode. Okay, this is the, these two electrodes, external wire connected to the galvanometer. This we call as galvanometer. This is one electrode. This is one electrode. This here it is a zinc electrode. It is a zinc electrode. Okay, it is a copper electrode. It is a copper electrode. Copper electrode always left side, always right side. Zinc electrode always left side. It acts as a anode. Anode means which attract the electrode, which attract the anion. Anion means negative charge. We call it as anode, and it carries positive charge. It carries positive charge. Okay, here right side we have the cathode. What is the cathode? The electrode which attract the cation. We call it as cathode. Okay, to attract the cation means it carries negative charge. It carries negative charge. Okay, anode always present at left side, cathode always present at right side. These two electrodes bring two electrolytic solution. Okay, same electrolytic solution. Here I am taking one electrolyte, I will give the name. Okay. Here zinc electrode bring zinc sulfate solution, zinc sulfate electrolytic solution. Copper electrode bring copper sulfate solution or cupric sulfate solution, cupric sulfate solution. And here these two connected with the one of the U shape, inverted U shape containing, inverted U shape containing, inverted U shape containing one glass tube, one glass tube. This is we called as salt bridge. This is we called as salt bridge. This is filled with the agar-agar jelly or potassium chloride, ammonium nitrate or potassium cyanide. This is filled with salt bridge contains agar-agar jelly, agar-agar along with the potassium chloride or ammonium nitrate. Okay, ammonium nitrate. Okay, this is the salt bridge. It is connected to these two. Okay, these two electrodes. It is connected to anode and cathode. Then first we'll see what is the significance of salt bridge. What is the use of salt bridge? What is the use of salt bridge? What it indicates here, salt bridge? Salt bridge indicates, salt bridge connect the two electrodes. One is cathode electrode and another one is anode electrode. Cathode electrode and another one is anode electrode. We'll see here significance of salt bridge. Okay, before seeing the significance of salt bridge, how many steps are there? One is construction of cell, reaction set cell, calculation of EMF, representation of linear cell. We'll see next. Okay, salt bridge made by salt bridge is, what is the salt bridge? It is one of the important question, 2 mark question. Sometimes when asked in NEET level also, what chemical composition is present in salt bridge? Okay, what is the salt bridge? It connects the two electrodes. One is cathode and anode near linear cell. It is a U-shaped tube, inverted U-shaped funnel. It contains agar-agar and potassium chloride or ammonium nitrate. What is the significance? Here I am discussing about the salt bridge. Significance of salt bridge. Okay, first point, it connected the two electrodes. Connects two electrodes or two solutions, two electrolytic solutions. Okay, that is the one of the important one. And here, okay, prevent transformation of solution from one electrode to another electrode. It prevents transformation of solution from one electrode to another electrode. That means anode to cathode or cathode to anode. Okay, and third important one, it also regulates electrode potential. Regulate electrode potential at anode and cathode. For example, zinc releases 2 electrons. Those 2 electrons definitely absorbed by the copper, Cu+2 ions. Okay, otherwise, the electrode potential increases at zinc, the electrode potential decreases at copper electrode. So, then the galvanic cell not working properly. Okay, for the regulating of those electrode potential, here, okay, we use the salt bridge. Salt bridge helps the regulating of electrode potential. These are the important 3 significances. One is connected to 2 electrodes. Second one, electrolytic solutions, prevent the transformation of solution from anode to cathode or cathode to anode. Regulate the electrode potential. Okay, that means not exceeds electrode potential. What is the meaning of electrode potential? Okay, here electrode potential means the potential which is exerted at. Okay, the potential which is exerted or produced at the anode or cathode we called as electrode potential. When it is absorbed in anode, when it is observed at anode, we call anode potential, and other one is called as cathode potential. Always at anode we observe oxidation reaction. The potential which is exerted by the oxidation reaction we called oxidation potential. At anode we observe the oxidation potential. What is the oxidation potential? Okay, the potential which is exerted at anode by the oxidation we call oxidation potential. Okay, one more is there. If potential which is exerted at the cathode by the reduction we call reduction potential. These two potentials which are observed at 25 degrees centigrade temperature, 1 atmosphere pressure. Oxidation potential or reduction potential which is observed at 25 degrees centigrade temperature, 1 atmosphere pressure, that we call as standard oxidation potential, represented with the SOP. Okay, this is measured in volts. Okay, if the reduction potential which is observed at cathode by the reduction at 25 degrees centigrade temperature, 1 atmosphere pressure, we call as standard reduction potential. This we call SRP, standard reaction potential. Okay, always at cathode reduction potential is observed. Reduction reaction is observed, so we indicate ER. Okay, here ER means E right, or sometimes we also indicate with E cathode also. E cathode. Here we use E left or EL. Also we use EL or ER. This is about the potential. What is the meaning of potential and what is the meaning of oxidation potential, reduction potential, standard oxidation potential, standard reduction potential. This is about the just significance of salt bridge. This is the first step, construction of cell. Then in continuation we will see the second step. The second step, reactions at cell. Here electrodes are there. One electrode and second electrode. This is complete electrochemical cell. And here the reactions at one electrode we call as off reaction, and one more is called as another off reaction. Here oxidation at anode, oxidation reaction takes place now. This is we called oxidation of reaction. At cathode, here reduction reaction takes place. So this is we called reduction of reaction. Two important reactions are observed at anode and cathode. Those we called off reactions. See, reactions are said. First see the at anode. Here, zinc electrode dipped in zinc sulfate solution. Zinc electrode dipped in zinc sulfate solution. Copper electrode dipped in copper sulfate solution. Copper electrode dipped in copper sulfate solution or cupric sulfate solution. Here, what happens here? First, zinc lose the electron. Why not the copper? Always in system, anode lose electron, cathode C+2 and gains the electron. But here, zinc lose the electron, Cu+2 ions Cu plus 2 ions present in this gain the these gain the electrons. These lose the electron, this gain the electron. Why? The standard oxidation potential of zinc electrode, the standard oxidation potential of zinc electrode, standard oxidation potential of zinc is here plus here 0.76 volts. 0.76 volts. Standard oxidation potential of copper. This can be taken by electrochemical series. In continuation, we will have electrochemical series. The value is minus 0.34 volts. Standard oxidation potential. This is the standard oxidation potential, means here our oxidation reaction takes place. So we took 0. Plus 0.76. Here reduction reaction takes place. So reduction SRP is plus 0.34. But here I am taking SOT. So minus 0.34 take. It is more. Which has more standard oxidation potential? That only involves in first that only involves in oxidation. Which has less oxidation potential? That involves in reduction. Here at iron, what happens here? Zinc lose the electrons. Zinc electrode. Remember here, zinc electrode lose the 2 electrons and forms zinc plus 2 ions. This is we called as oxidation and only this it is absorbed in only one electrode, so we called oxidation of reaction. This is we called oxidation of reaction. The electrode is E left, it is presented left, E left is equal to here 0.76 volts. And the concentration of solution, this zinc sulfate solution, always 0.1 m, sometimes we use 1 m also. Here 1 m, here also 1 m. Here also 1 m and 1 m. Concentration of this solution is in both cases 1 m only. This is the oxidation reaction finished. Next is the second one at cathode. Here at cathode, Cu plus 2 ions are there. Cu plus 2 ions which are present in a cupric sulfate solution. Those Cu plus 2 ions gains the electron which are moved from external circuit. Here electron moves now. Those electrons moves from external circuit to copper electrode. Those 2 electrons gained by the Cu plus 2 ions and reduction reaction takes place. See here, Cu plus 2 ions gain 2 electron and convert into copper. Copper. This copper deposited at copper electrode. This is we call as reduction of reaction. This is the oxidation of reaction. Here it is right side ER. We call as ER. It is 0. SOP of this one is 0.34 volts. 0.34 volts. And here one more thing. Here zinc lose the electrons and converting into zinc plus 2. These zinc plus 2 ions are mixing with the solution. That means the weight of zinc, here weight of zinc decreases. Weight of zinc electrode decreases. After the reduction, all the Cu plus ion get deposited at copper. Get deposited at copper. That means copper electrode, weight of copper electrode increases. Weight of copper electrode increases. Weight of, okay, here weight of copper electrode increases, weight of zinc electrode decreases. Okay, this is about the reaction set. Okay, reaction set, different electrons. See here overall reaction. Okay, overall reaction. What is the first reaction? Zinc loses the 2 electrons and forms zinc plus 2. Here Cu plus 2 ions gain the 2 electrons and form the copper. This is the oxidation of reaction. This is the reduction of reaction. What is the final reaction? Overall reaction. 2 electron get cancelled. Zinc as Cu plus 2 gives rise to zinc plus 2 plus C. Okay, this is the overall reaction of Daniell cell. Overall reaction of Daniell cell. You remember these two? E left, E right. Okay, SOP means this is E left, this is E right. Remember these two. Next, in continuation, we will see the calculation. We will see here calculation of EMF, electromotive force. Electromotive force means the total potential which is exerted at 2 electrodes are in cell we called as EMF. Third step. Calculation of EMF, electromotive force. Okay. EMF is the difference potential, total potential at the difference potential which is observed at cell. Are 2 electrodes be considered as a EMF, electromotive force. EMF is equal to E right minus E left, or E anode minus E cathode. E anode minus E cathode. Okay. What is the E right? Already I gave the data. E right means SOP, standard oxidation potential of zinc, 0.76 volts. E left SOP of copper is equal to minus 0.34 volts. And here EMF is equal to E right means 0.76, okay, minus 0.34 is equal to 0.76 plus 0.34 is equal to 1.10 volts. EMF of Daniell cell is 1.10 volts. EMF of Daniell cell is 1.10 volts. Okay, this is the calculation part of this Daniell cell. Okay, next in continuation, 4th step, representation of electrode. How we represent the electrode? This is also one of the important one. Not only here some rules are there. We'll see representation of cell. Okay, representation of cell. First, over here some rules are there. Left side right anode, this is the first rule. Second rule, right side right cathode, right side you write the cathode. Anode and cathode, anode and cathode, both are connected to here salt bridge and connected to two vertical lines. This represents salt bridge. Two vertical lines represent the salt bridge. Okay, while writing the anode, how we write the anode? First write the metal, that means solid part, and okay, take the one vertical line and write the metal ion. Write the metal ion. And one more thing, at the metal ion you write the concentration of the solution. Here 1m concentration is there, that solution will write in within the bracket. With the 1m means 1 molar, normal is there means you write it normal, 1m. Next, cathodic part you write first metal ion, metal ion and metal. Metal ion and metal separated with the one vertical line. Here write 1m concentration. That means 1m concentration, 1 normal, 0.1 normal, deci normal or any other concentrations are there. You write like that. Okay, these are the steps involved in representation of cell. Okay, here we have got two cells, two electrodes are there. One is anode is there, one is cathode is there. Anode is zinc electrode, cathode is copper electrode. Here I am representing cell. Left side write anode. Anode means zinc. Zinc how we write? First we will write metal and then metal ion. Then one is over. Next right side write cathode. Okay, right side write cathode here. Cathode how we write cathode? First write the cation, then electrode. Cathode and anode. This is the anode, this is the cathode. These two are connected with the salt bridge. And the concentration of these two solutions 1m. You write here 1m. At the ion I say at the ion. Here also you write the 1m. This is the complete representation of the cell. This is about the representation of the cell and construction of the cell, reaction set, cell, and here construction of the cell, calculation of the cell. This is about the complete Daniell cell. Daniell cell involves complete Daniell cell explained in 4 steps. One is construction of Daniell cell, second one reaction set Daniell cell, and third one calculation of EMF Daniell cell, and fourth one representation of cell. This is about the first one of the important topic in electrochemistry. Next in continuation we will see some more electrodes.